Good afternoon, everyone. So let us continue our discussion. So in the previous lecture, we have discussed about the round robin algorithm, and we have taken these three applications, and we assume that the first application is submitted in the best effort mode, second application is submitted in the AR mode, and third application is submitted in the B mode, right? And based upon the arrival time of these tasks, we are scheduling it into three different clouds, right? That means 12 different tasks based on their arrival and based on their precedence constraints. We have to schedule these 12 different tasks to three different clouds. Okay, but we have seen in the case of round robin algorithm that the main problem is that we have predetermined the order, like first task to the first cloud, second task to the second cloud, third task to the third cloud, and fourth task to the first cloud, as you have three different clouds. So this ordering sometimes may cause problem, and we call that as a load imbalance problem, right? Or load balancing problem, as the loads are imbalanced in three different clouds. Now, what we will do, we will take this least scheduling into consideration. And as I mentioned, least scheduling case, you have to choose one cloud out of these three clouds, which takes less time. Okay, like here we have seen for task A, it is taking 2 units of time in cloud 1 and 3 units of time in cloud 2 and 5 units of time in cloud 3, out of which the minimum one is cloud 1. So we can assign to the cloud 1. So let us go for the least scheduling and solve the same problem. So what you can do, you can take a Gantt chart like this by making 4 different columns, right? One column you can give for the timeline, another 3 columns are for 3 different clouds, right? For example, this is, I can say, time, and second one is cloud 1, next is cloud 2, third is cloud 3, right? And take some time slots like this. Some rows you have to take. Each row represents one time slot, and we'll write the corresponding task name in cloud 1, 2, and 3 respectively, right? So let us start. Time, let us start from 0 to 1, then 1 to 2, 2 to 3, 3 to 4, and one task is arrived at 0 unit of time, that is our application 1. 3 to 4, another application arrived to the system, that is application 2. Then 4 to 5, 5 to 6, 6 to 7, 7 to 8, 8 to 9, 9 to 10, and 9 unit of time, you can see application 3 is arrived to the system. Let it be 10 to 11, 11 to 12, 12 to 13, 13 to 14, 14 to 15, and so on. Let's say 15 to 16, and so on. Okay, we'll see based upon our need, we'll extend this timeline. So first, you know, at 0 unit of time, the only task that is available in our system. Okay, the only task that is available in our system is A, right? Because BC is not ready at the time. Because once A is ready, then only A is completed, then only you can schedule B and C. So we'll go to task A and we'll see the time it required in cloud 1, cloud 2, cloud 3. So this matrix is actually sometimes referred as expected time to compute matrix. Okay, that is called as sometimes ETC matrix. Okay, so if I check for task A, then it is taking 2 unit of time, 3 unit of time, 5 unit of time in cloud 1, 2, 3 respectively. So out of which you can see the minimum one is 2, right? That is in cloud 1. That's why task A is going to be assigned to cloud 1. So let us assign task A. I'll assign task A here, cloud 1. So it will take 2 unit of time. Okay. So task A takes 2 unit of time in cloud 1. So it is successfully executed, right? Now once A is completed, you can see this task F, which is belongs to AR application, that is going to arrive the system at the 3 unit of time. Right? F is going to arrive 3 unit of time, but till now we reached up to 2 unit of time. So we can take the decision of B and C. Okay. So you can see for B, if you choose the minimum one, B the minimum one is, that is 4. That means third cloud. And C case, the minimum one is second one, that is second cloud. So B can be assigned to the third cloud, which takes 4 unit of time. C can be assigned to cloud 2, which takes 3 unit of time. So let us assign B first to the third cloud. So B is going to take here after completion of A only you can do. So it is taking 3 unit of time. Right? So now B is completed. Okay, A is 2 unit of time, B is 4 unit of time. That is completed. Now come to C. C can be assigned to which cloud? C can be assigned to cloud 2. Right? C can be assigned to cloud 2, which takes 3 unit of time. In which cloud? That's cloud 2. Right? So I can write C 3 times. Right? Oh, sorry. B is 4 times, not 3 times. B is assigned to cloud 3, but it is 4 times. So here you can see the time, right? In C case, it is 3 unit of time, but assigned to cloud 2. So now A, B, and C, these 3 tasks successfully completed. Right? Now, what you can do? This is decision you have taken at 2 unit of time. Okay, although it is assigned before assigned 3 unit of time onwards, right? But the decision was taken at time 2, right? Now at 3 unit of time, you can see a AR application arrived to the system. So the first task which is ready, that is F, and you need not worry about D and E till B is completed. Before that, we are taking the decision for task F, and task F is the root task, right? Task F is the root task. So first we need to execute task F, then we have to think about, you can say, okay, we can think about task G and onwards, right? So if you go for task F, okay, task F takes 4, 2, 3 in 3 different cloud. Okay, so out of these 3, you can see it is taking least time in cloud 2. Okay, it is taking least time in cloud 2. So you can assign cloud 2 at this particular period of time, this instance of time, but it is an advanced reservation task. So as it is an advanced reservation task, what you have to do, if there is any B task running in your system, that you can preempt. So if I put B here, sorry, F here, F is an advanced reservation task, C is an best effort task, so we can preempt C. Okay, because F is scheduled in cloud 2. That is the reason why you are preempting, right? So again, I'll make a cross mark here that indicates that I preempted task C, and I can assign F. So now F is successfully completed, okay, in the second cloud. But C requires 3 units of time in cloud 2. 1 unit of time already done. Another 2 units you have to give in upcoming slots, right? Now, once F is completed, you can think about G. Okay, if you go for G takes minimum time in cloud 3. Okay, so if I write G here, then again there is a confusion between B and G. B is a which task? Because both tasks needs the same time slot. So G is an advanced reservation task and B is an best effort task. So what we can do? We can print this best effort task and we can continue the task G for 4 units of time. Right? So now B actually require 4 units of time in cloud 3. 3 units you have already given. 1 unit it is printed. So in future you have to give 1 unit of time. Okay. I have to assign 1 unit of time in the upcoming time slots. Okay, so F and G is also completed now. Now you can think about H and I also, right? Because B is not completed. B is not completed. C is also printed. Until unless B is completed, you cannot start D and E. D has to wait until unless B is completed, right? So what we can do here? So we can think about H and I. Okay, and where you can assign H, I you can assign after G, right? Because G is the you can say parent of H and I, right? So I can resume 2 units of C here, right? And once G is completed, I can think about H and I. But at the same time, you can see another application also arrived to the system. Which application? Application number 3 is arrived to the system. But application 3 is submitted in the B mode, and H and I are the task of advanced reservation, right? AR task of AR application task, right? So H and I need to be given priority. So if you look into H, right? H is taking minimum time is 2 in the first cloud. So I can start H here, right? Now H is completed. What about I? I also need 4 units of time. So I also can make a competition with H. But what I told you, a AR task cannot preempt another AR task, or a B task cannot preempt another B task. So I can write here I, and I. Okay, only after that AR task you can give the slots to I. So now I is also completed. Okay, now before considering this JKL, okay, JKL, you can see in the cloud 3, B is printed. So B should be resumed after G. So I have resumed B here, right? I have resumed B here because I told you if there is 2 B tasks, one B task has not started, another B task is partially completed. So you have to give priority to the partially completed task, right? So it is completed. Now J is ready. Okay, at this time J is ready. J takes 4 units of time out of 3 clouds. The minimum one is 4 in the cloud 2. So I can start J here. J 4 unit, right? 3 unit and 4 unit. Okay, 4 unit of time. Okay, we can assign J, right? Now, once J is completed, you can take decision for KL. KL decision you can take it 13 unit of time. But prior to that, you can see here, B and C both are completed. If B and C both are completed, you can start D and E. If you look into D, okay, 7, 10, and 5, out of which one is minimum? The minimum one is 5. Okay, so I can write here D1, D2, D3, D4, D5. Right? Similarly, you can take the decision of E. Okay. At this time, only you have to take the decision of E, because E is also now an independent task. V is completed, C is completed. That means both D and E, they are independent. So E can be also scheduled. But once you look into E, what you found? You found that it takes 2 unit of time in cloud 3. 2 unit of time in cloud 3. So it can be only assigned at this position. Because once D is completed, then only you can start E. Right? You cannot print one B task, cannot print another B task. And if you see D and E, both are the B task and they have not started. If one partially completed task is there, then it can give priority. But as none of the task has started, so you can consider that they are the new task and they should be processed in one by one. Okay. Now, once J is completed here, you can take the decision for KL. So if you look into K takes minimum time in cloud 2. So I can start K here. K, and K, 3 unit of time. Similarly, if you look into L takes 2 unit of time, which is minimum among 3 clouds. Out of 2, 3 and 4, the minimum one is 2. Right. So L can be assigned, although you are taking decision here, up to this there is no slot is vacant. Okay, you can start L here. If it is first cloud, you can start. But I and L, I is a which task? AR task. L is a B task. So an AR task cannot be preempted by a B task, because AR has more priority of the B task. So once that AR task is completed, you can start L for 2 unit of time. So at this particular period of time, all the tasks are completed. Okay. But if you see the previous algorithm, which we discussed in the morning session, okay, the make span is 30. But what is the make span here? Or total completion time of all the tasks? Can anybody tell? What is the overall completion time? In the previous algorithm, we have seen 30. But what is there in the, what is the make span of this cloud scheduling? What is the make span, overall one? Overall one is 17, right or not? It is 17. So you can write make span, calculation of make span. So for make span, you have to find local make span. Means first one you have to find, let's say, make span of cloud 1. MC1 means make span of cloud 1. So it is 17. Make span of cloud 2, which is equal to 16. Make span of cloud 3, which is equal to 17. So we found the make span of 3 different clouds. Now, if you want to find overall make span, okay, let us find overall make span. Overall make span is nothing but maximum of, okay, 17, 16 and 17. So you will get the value as 17. Okay, this is nothing but the make span of 3 different clouds. And the maximum of that is called as overall completion time, because you have given 3 different applications at the same time. Okay, so out of these 3 applications, which one is the later one? The later one we found in cloud 1 and cloud 3. Okay, that is maximum time, right? So it is 17. Similarly, if I ask you to calculate the utilization, let's say for utilization, I'm taking a function U, UC1, UC2, and UC3. Okay, so utilization of C1 is nothing but local make span, that is 17, divided by this overall make span. So this you can consider as a local make span. And this you have to consider as overall matrix. Okay, so you will get 17 divided by 17. So UC2 is, it is nothing but 16 divided by 17. NC3 is also nothing but 17 divided by 17. Okay, so you got utilization. Now, if I ask you average utilization, average cloud utilization, average means, you know, if three values are there, that is 17 by 17 plus 16 by 17 plus 17 by 17 divided by 3. Okay, that will give you utilization. And if I ask you to calculate the average utilization, but show the result in percentage. So average utilization in percentage. What you have to do? Once you calculate this thing, right, you have to multiply by 100. Okay, how much you are getting? Can anybody calculate and tell me? How much you are getting here?
Sorry, 98%.
You are getting 98%. Okay, so if you calculate here, it is 1. 1 means it is 100%. It is also 1 means 100%. Only you need to calculate 16 divided by 17, which is coming as 0.94. So total is 2.94, right? If you sum these three values, you will get 2.94 divided by 3, you will get 98.04%. Okay, so this is your utilization. Now we have another factor. What is that factor? That factor is called as idle time. So how to calculate idle time? You can see these slots are idle. You can write 1, 2, 3, 4, 5, 6, and 7. The total idle slot, if I write IC1, idle time of C1, it is equal to how much? 7. Similarly, I of C2, if I ask you to calculate, you can say here there is a slot 2, here also there is a vacant slot 3, 4. Okay, that is 4. Okay, and I of C3, which is equal to, here you can say 1, 2. Okay, so it is 2. So if I calculate average idle time, average idle time, so it is 7 plus 4 plus 2 divided by 3. So 13 by 3. How much you will get? You will get 4 point something, right? 4.33. Okay, or you can say 34. So that is nothing but the average idle time. Okay. So in this way, you can deal with these two algorithms. One is round robin scheduling, another is list scheduling. Now, can you please guess what is the drawbacks of list scheduling? Like round robin case, I told you there is a predetermined order, like 1, 2, 3, which is not good. Without looking into this expected time to complete matrix, you are taking decision. But here, by looking into this matrix, you decided which one takes minimum time. Okay, and you have a better, you can say, better make a span. Like previous case, you got 30. In this case, you are getting 17. So obviously, it is a better one. But if you go for, if you can think that in what way this algorithm is also having limitation. Like one of the example I'm telling you, the limitation of this algorithm. Like here you can see this D and E, right? D and E both are ready at the same time after execution of B, right? But as both D and E takes the minimum time in cloud number 3, okay, they are taking minimum time in the cloud 3. So the problem is that they can be processed in 1 by 1. So D first, E second. Okay. Assume that at that time, let's say cloud 1 is free. which takes 3 units of time more than cloud 3. If you look into E, so you can say it is taking 3 units more time in comparison to cloud 3. So if it is vacant and it is free, then you can assign. But this policy does not consider this one, or this algorithm does not consider that one, right? So which increases the McCaskill value. So which is can be improved by considering another efficient algorithm, right? Like that, you can find some of the drawbacks related to this particular algorithm. Yes, because there is a drawback, then only we can think about another algorithm, right? So let us proceed to another algorithm. Okay. So better what I'll do, let me erase this thing. Okay, let me open a Microsoft Word so that we can easily write this thing. Okay. So I created a word. Let us solve the same problem with another way, another efficient algorithm. So let me save it in my desktop so that I can share you this solution later. Okay. So let's say one algorithm that is called as minimum completion cloud. Okay, that is called as MCC. Okay. So for this, let us go through a chart with 20 rows or 21 rows, and we need 4 columns, right? Okay. Now, so here it is a little bit easy. That's why I have used this one. Okay, let me write here time. Okay. Yes. So I created a Gantt chart, right? So I'll write cloud 1 here, then cloud 2, and cloud 2. I'll show you the solution. Whatever we are doing there, we'll do the same thing. But it is better if you write in a word, okay? So that you can easily write. So I'm giving the timeline like this, 0 to 1, then 1 to 2. Let's make it material alignment. Okay. Okay. Okay, 0 to 1, 1 to 2, then 2 to 3, 3 to 4, 4 to 5, 5 to 6, 6 to 7, okay, 7 to 8, 8 to 9, 9 to 10, 10 to 11, 11 to 12, 12 to 13, 13 to 14, 14 to 15, 15 to 16, 16 to 17, 17 to 18, 18 to 19, and 19 to 20. Up to, let us go for 20. Okay. If it is required, then we'll expand. Right. Now, you tell me at 0 unit of time, you receive task A. Right. So you're making it bold. 3 unit of time, you will get another application. And at 9 unit of time, you will get the third application. So I'll make it bold color so that you will not forget while your allocation. So what you will do? So here, if you go for minimum completion cloud, so minimum completion cloud says that not only you have to consider the execution time. Which one is execution time? This is called as your execution time. Okay. But also you have to consider the ready time. One of the non-technical example I'll give you so that you can understand what is the need of this algorithm. Let us consider you have 3 friends, right? You have 3 friends. Their name is A, B, and C. So you have a work, let's say W. right? You have some work, that is W. If you ask help to A is taking 2 units of time. If you ask B, it is taking 4 units of time. If you ask the same thing to C, it is taking 6 units of time, right? So you can see here, obviously, if you go for the least sibling algorithm, least sibling says that you have to assign to cloud A, right? So this is with respect to the execution time. But as you have asked help to A, you should know what is the workload of A. Sometimes you are asking a help to a particular person without knowing that whether that person is busy or not. Let's say A is now busy for 5 units of time for providing help to some other friend. Okay, you are not only the person asking help. Let's say other persons are also helping, asking help to A. So for that, A is busy for 5 units of time. Okay. B is busy for 1 unit of time. C is completely free. So that's why 0. So this 510 is called as your ready time. So you have to find completion time. Completion time is nothing but execution time plus ready time. So what is the execution time here? 2. Ready time is 5. So completion time is expected at 7 units of time. Right? For B, it is 4 plus 1, so 5. For C, it is 6 plus 0, 6. So once you find the completion time, the minimum completion time you are getting in the case of B. So although A takes less time, because A is late, so it is better to ask the help to B. You can take another example, non-technical example. Suppose you want to travel a location X to Y. You reach to a railway station. You have not booked your ticket. So you have seen there are 3 different trains. One train is delayed by 5 hours, but takes 2 times to reach to your destination. Another train delayed by 1 hour takes 4 units of time, 4 hours time. Another train which is ready in that station, but it took 6 units of time. So you have calculated when you will reach to the destination. Here you can see you can reach the destination after 7 hours. You can reach to the destination after 5 hours if you go for the B train. If you go by C train, then it is going to reach by after 6 hours. So obviously you are going to choose B option, right? So you need to calculate the completion time, execution time by adding execution time and ready time. But initially we assume that all the clouds are free. Okay, means their ready time is 0. Okay, so let us go back to the solution. So first task A is coming. So it is taking 235, right? It is taking 235 and ready time is 0. So execution time is equal to the completion time, and vice versa is also true. Right? When ready time is 0, completion time is equal to execution time. So what you can do, I can assign task A here for 2 units of time. Okay. If you assign to cloud 3, it is going to take 3 units of time. For cloud 3, it is taking 5 units of time. Right? So now task A is completed. Now once A is completed, you can think of B and C. Okay. B can be started at this particular time. B and C both can be started at this particular time. So it takes a minimum time in cloud 3. So I will assign to cloud 3 because their ready time is 2 in each and every cloud. So they are taking 684, right? In C1, C2, C3. But what is their ready time? Ready time is same for all. They can start at the 3 unit of time. That's why their ready time is 2. So if you sum, it is 8, 10, and 6. So obviously the minimum one it is coming is 6. Okay, in the cloud 3. So I have assigned to cloud 3. Now, can you guess for a C? What about C? Can anybody guess where I will assign C? C guess. Can you guess which cloud I am going to assign? Which cloud you will assign? C case. You can see C1, C2, C3. It is taking 5, 3, and 8. Right? But you know, you can assign only after 2 unit of time. Because once the parent will give you the result, then only you can do it. Right? Similarly, C2 case also it is 2. But C3 case it is not 2. Because B is already assigned. Okay. So it is ready after 6 only. So it is 7, 5, and 14. So I'll assign to C2. So what I can do, I can assign C in the cloud 2. Right, I don't know whether it is going to complete or not, right? Because AR task is going to come in future. So sometimes it may create problem for this B task. But as we are taking the decision at a 2 unit of time, we can say this is the decision, right? So now C is completed, then we can think about other tasks, but at 3 unit of time, F is arrived to the system. So for F, even if a B task is there, but AR task is much more powerful. Okay, F task is much more is priority over the B task. So I can start F here by printing C. I can start F here and F here. Okay, so you can strike out F. So let me strike out C. So I have printed C. It is as it is a B task, and I have assumed the work of F because F is more priority. Okay. Okay, just a minute. I'll open the PPT so that we can directly do it. Yeah. So let me make it in this way so that we can directly solve this problem. Yes. So now I have printed task C. I have started F. Once F is completed, what you can do? Okay, once F is completed, you can start G and G. Okay, G is going to be executed in which cloud? It is going to execute in the last one. Okay, why I am not considering ready time here? Because even if there is a B task is there, you have to print it. That's why there is no need to consider ready time here. So I'll assign G here, G here, G here, G here. Right, 4th time I have assigned G, and I have to strike out this one. Okay. So G I have striked out. A B is printed and G is started its execution. So once F is completed, you can resume the work of C, and once G is completed, you can resume the work of B. Right? Now A and F and G is completed. BC is completed after that. Right? So next you have to think about once G is completed, you can start and H and I. So H case, the minimum one in first cloud. So I can start H here. Right? But I case, the minimum one is again cloud 1. Right? I case, the minimum one is cloud 1. But H is assigned here. So I is 457. Now it is changed to 657 because H is an AR task. As H is an AR task, if you want to schedule I here, suppose let's say I'll make I here. then what happen? It is going to complete at this particular time. But if I start I here, although it takes more time, 5 units of time, it will complete early than this one. That's why I want to take that solution. Is it clear why I have scheduled I in the second cloud, although it is not the minimum one? Is it clear? Okay. So why we assign? Because if you assign I, it is taking more time because of H, and I cannot print H because both are having same priority, right? That's why I have assigned to the next one, right? So now all the AR tasks are completed. So we have to think about the BE task, right? So if you see J is another BE task. At what time it is taking 846. If you assign here, it will take 8 units of time after this one. But you are taking this one at 9 to 10. Okay. But if you assign, let's say in the cloud 2, it is taking 4 units of time. So let me show you the mapping so that it will be more clear. So J will start here. So it is going to take 8 units of time, 4, 5, 6, 7, and 8. And it is taking 4 units of time in cloud 2. So I can assign only after I because I is an AR task. And similarly, I can start J here, 1, but it is taking 6 units of time, 4, 5, and 6. So which one we are getting earliest completion time in cloud number 3. So I have to assign it to cloud 3, and I have to remove this matching. Right? Now, once J is completed, you can start KL. But B is completed here. As B is completed here, C has already completed. You can think about D and E. But if you go for D, D is taking 7 units of time. 1, 2, 3, 4, 5, 6, 7. And D is taking 10 units of time. So 3, 4, 5, 6, and so on. Okay. And D is taking 5 units of time here. So all are taking, this cloud 2 and cloud 3 is taking more time. That's why D need to be scheduled here. Although it is quite more. Okay, in terms of execution time. Okay, then the last one. Okay, that is 7. This is 7, and right, the cloud 3 is 5. So we have assigned here. Right. Now D is completed. So think about E. E takes 5 units of time, but takes 2 units of time in the last cloud. So if I take 2 units here, okay. If I take 9 units here, it takes more. You will exceed this E. Okay. So earliest time you will get here. Okay. So DE is assigned to cloud 1 and cloud 3 respectively. Is it clear why it is assigned to cloud 1 and cloud 3? You can match it, right? Because the process of mapping is nothing but matching and scheduling. Okay. So first you have to match with all possible cloud, all the available clouds. Out of these all available clouds, you have to actually choose the best one. So like here we choose D case, we have chosen cloud 1, and E case 2 we have chosen cloud 3. Right? So now D and E is completed. So all the D is completed. Earlier you can see F, G, H, I is completed. J is completed. Now you have to think about K and L. K case. Okay, K you can schedule here. So K, it takes 9 units of time here, 3 units of time here, okay, and 7 units of time in cloud 3. Okay, so obviously you are going to choose the cloud number 2. Okay. Similarly, if you go for L case, L is taking 2 units of time. Okay, 2 units of time here, and L is taking 3 units of time. So it will exceed this limit, and L is taking 4 units of time. So it is also exceeding this one. So in this way, you can make calculation of completion time, which is the sum of ready time and execution time in order to schedule the task to different clouds. Okay, check whether all the tasks are executed or not. A is there, B is completed, C is completed, D is there, okay, E is there, F is there, G is there, H, I, J, K is there, L is there, right? So all the tasks are assigned. So now if I ask you, calculate the make span. Okay, calculate the make span. So if you calculate the make span is nothing but maximum of 3 cloud. What is the make span of first one? That is 20. Make span of second one, 19. Make span of the third one, that is 18. So you will get the overall make span is 20. Right? Now, if I ask you, you can write also, make a note of this one. Make span of cloud 1 is 20. Okay. Make span of cloud 2 is 19. Make span of cloud 3, that is 18. Okay. So maximum that is 20. Now, similarly, can you calculate the utilization? Utilization of cloud 1. Similarly, calculate the utilization of cloud 2 and utilization of cloud 3. Can you calculate and tell me this value? And calculate average utilization or overall utilization. And also calculate average utilization in percentage. Okay. Calculate it. It's simple. Similarly, you have to calculate idle time of cloud 1, idle time of cloud 2, idle time of cloud 3. Then you have to calculate average idle time. Okay, calculate this thing and tell me. Okay, let me show you the schedule also.
Utilization cloud 1 is 1.
Cloud 1 is 1. Okay.
0.95.
One, let me write like this. So at the point of time also you can, if you look into, you can understand. 20 by 20 it is 1. Yeah. Next is
19 by 20, that is 0.95.
okay. Next
18 by 20, that is 0.9.
0.9. Okay.
Average utilization is 0.95, 1 plus 0.95 plus 0.9.
Okay. Let me write 20 by
Divided by 3.
20
Yes, sir.
plus 19 by 20 plus 18 by 20 and the whole divided by 3. How much you are getting?
Sir, 0.95.
Yeah. 0.95. If you calculate in percentage, you will write simply 0.95
Multiply with 100.
100, yes. You get 95%. Let us see the idle time. Idle time, you can put 1, 2, 3, 4, 5, 6, 7. So idle time is 7. Then here you can see cloud case 1, 2, 3, 4, 5, 6, So you can see ideal time is 6. Here ideal time you can say 1, 2. Okay, there's 2 only, right?
Yes, sir.
So average means you will do sum of these values, 7 plus 6 plus 2 divided by 3. How much it is coming?
Sir, is that 5?
5, yes. 13 plus 2, 15, yes. It is 5. Okay. So in this way, you can solve this problem. I'll save this file. This minimum completion cloud. Okay, if you have any doubt, you ask. Like that, you can think about other algorithms. These are the simple algorithms. Okay. Now something comes to your mind actually. How to generate these actually workflows, right? Or applications or directed acyclic graphs. That is very much important. Because is there any standard directed acyclic graphs you can use when you perform task scheduling? Okay, so you can see to evaluate these workflow scheduling algorithm or this application based scheduling algorithm or task scheduling algorithm, we should measure its performance on some sample workflows. Okay, so while we are talking about sample workflows, where you will get these workflows, right? So there are two ways to choose the same sample workflow. First is you can write a simple code to generate this directed acyclic graph or application or workflow. Okay, using a random directed acyclic graph generator, you can generate variety of workflows with different characteristics. For example, you can write a program by giving input the number of tasks. Okay, you will give input number of tasks. For example, I need the number of tasks is 5. Then I have to mention what is the depth. Depth I can consider as 2. Let's say another is width. Width I am considering as, let's say, 3. So somebody can say this is a directed acyclic graph. Okay, having 5 nodes, right? 1, 2, 3, 4, 5. You can say depth is 2, right? Width is also less than 3. Okay, that is 2, right? Somebody can say like this also, 2, 3, 4, and 5. There is also width is 3, depth is 2, and number of tasks is 5. Right or not? So similarly, you can generate by writing a simple code, you can generate number of directed acyclic graphs. So you have to take this input and you have to design. You have to generate the directed acyclic graph. Once you generate directed acyclic graph, you generate multiple directed acyclic graph. Consider few as AR mode, few as B mode, and assign it. Okay, few are AR mode, few as B mode, and assign it to by assuming 3 clouds or 5 clouds or 6 clouds, whatever may be, right? As an alternate way, what you can do, you can use the library of realistic workflows. There are some workflows there in scientific community. That workflows you can use, and these workflows are not just a simple workflows. These are realistic, which is used in real life. That can be used for any scientific purpose, any business purpose, or targeting a particular application. Such library you can use and implement the realistic workflows. Okay. So the structure of these 5 realistic workflows. So basically there are 5 realistic workflows I want to discuss here. But although the number of workflows we have, And these scientific workflows are actually belongs to various scientific applications. For example, one of the workflow name is called as montage. So montage is a very popular workflow which is used in the astronomy application. And the structure of these workflows are different in terms of number of tasks, in terms of number of depth size and width size. Right? So another application you can see that is called as CyberSec. It is also a scientific workflow or real workflow which is used in the earthquake science. Similarly, epigenomics is another workflow which is used in the biology domain. LIGO is another workflow which is used in the gravitational physics. And SIPST is another workflow which is used in the biology domain. So that's why I told you these workflows are not random workflows. We can write a code and generate the random directed acyclic graph. There is no issue. But standard workflows or realistic workflows you can find by downloading the workflows of these 5 applications. Now you may ask how actually these workflows looks like. So let us see one by one. So these are the 3 workflows you can see which belongs to montage, epigenomics and SIPST. Like if you go for montage, how many tasks are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Number of tasks is 20. Okay. Number of tasks is equal to 20. What is the width of this directed acyclic graph? Can anybody tell? What is the width and what is the depth? Okay, if you consider root is depth 0, 0, 1, 2, 3, 4, 5, 6, 7, 8. So depth is 8. What is the width of this flow? This graph, width of this graph? 6, right? Width means maximum how many tasks can be assigned at the same time. Okay, like here you can see, I can assign these 6 tasks at the same time. Okay, but when I go for epigenomics, this is for montage. If I go for epigenomics, so you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So here also we are getting 20. What is the width? Width is 4. Depth is 0, 1, 2, 3, 4, 5, 6, 7. Right? Like that for SIPST, what you will get? You can count 1. Okay, any order you can start from here also. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, let's say 28, 29, 30, 31. So total task is 31. Okay. Width is, what is the width of this graph? Determining width is also very difficult in this case. So at max, you can say the width is, if you consider this is 4, and let's say these are also belongs to same level, if you think. So it is at max 8, right? So it is approximate. Then you can say depth, it is 0, 1, 2, 3, 4, 5, then 6 and 7. Okay. But in this case, you can see 0, 1, 2, 3, 4, 5. Okay, maximum will take. Okay, maximum will take. So it is 7. So you can see with respect to these scientific workflows, there are number of tasks, number of width, size, width size and depth size is different. Similarly, you can go for LEGO. LEGO case, you can see how many tasks are there. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, and 40. The number of tasks is 40. It is quite more in comparison to other workflows. Width, you can say width is 4 and 9. So it is 4 and 4 and 9. Yes, width is 9. And depth is 1, 2, 3, 4, 5, 6. Right. Similarly, cybersec case, you can say number of tasks is less only in comparison to the previous one. So it is 20, right? Number of tasks is 20. And width, you can say 8. Number of width is 8. And depth, you can say it is 0, 1, 2, 2, 3. If you consider this one is 4, okay. So you can take 4. This is the approximate one, right? So like that, you can generate the directed acyclic graph by taking number of tasks, width size, and depth size. Or you can use this realistic workflows. Then you can generate the time. What you need? You need two things. Like if I take LEGO and cybersec, let's say as a 2 application, I can consider this is, let's say, as a B application, and this one is AR applications. Right? So what you need a task ID, right? Some ID, as I mentioned, 1 to 20, you can give easily, right? And these 2 applications, if you are taking as input, you also need to define what is the arrival time. And also you need to find, if I consider 3 different cloud 1, cloud 2, cloud 3, okay, then what we have to think, we have to see that cloud 3, then suppose I told you here there are 40 tasks are there, for example. So out these 40 tasks if I take, then what is the time taken by each and every task in these 3 different cloud, that you have to actually generate. So normally we generate using the random function, which you know in C and C++. So if you specify some random number, okay, so although the random numbers can be generated in the range of 0 to 1, okay, or you can generate the random number by giving some range. For example, I can say minimum value I want to take is 2, the maximum value I want to take is 10. So all the task is taking 2 to 10 unit of time, in between 2 to 10 unit of time in each and every cloud. So I can generate this etc matrix, which I can give input to my algorithm, right? In that way, the problem is going to be solved. That's why we are generating these workflows, and we are evaluating in terms of the round robin algorithm, or you can say least scheduling algorithm, or modified minimum completion cloud algorithm, right? So this is one type of scheduling algorithm. Generally, we call this is a workflow scheduling algorithms. Now I'll tell you another interesting workflow. Like here you can see one workflow. This is another problem which considers only one workflow into consideration, not multiple workflows. It also does not consider whether you have to deal with a advanced reservation task or you have to deal with also not specified, right? Whether AR task is there or B task is there. Okay, all the tasks are having same priority. Another difference you can find with the previous algorithm, like you consider the computation time. Like if a task A is there, then B is there, and C is there. Let's say D is there, and E is there. Okay, like this. Then you are considering only the computation time. That is the node value, right? But you are not considering the communication time between two different nodes. That is missing. But here you can see, if you look into this, here it shows the computation time as well as communication time. So this can be considered as a computation time. This is also considered as a computation time. And these values, which I represented in the form of a rectangle, that is called as my communication time. Okay, communication time, right? So in this way, these two are different from each other. These two problems are different from each other, right? So what you can see here, irrespective of the number of, you can say, processor is taken into consideration. Like previous case, we consider 3 different clouds. But in this case, we can consider 3 different clouds or 4 different clouds, whatever may be. But it takes the same unit of time. Like if it is taking 5 units of time, that means irrespective of the processor, it is taking 5 units of time. So we consider here a homogeneous processors because they are identical. So they are taking the same unit of time. But previous case, we consider they are heterogeneous because they are taking different unit of time in different processors. Now, what you can do here, like here it is given 6 different tasks, and we have their computation time and communication time. So we have to decide out of these 6 tasks in which order actually we are going to process this task. Whether we'll follow T1, T2, T4, T3, T5, T6 order or any order. Okay, obviously we'll start from T1 and you will end up with the T6. But in between there may be a change, right? So in what order actually you have to dispatch the task, that depends upon some of the scheduling measures, right? So some of the scheduling measures I will tell you with respect to this one, so that you can calculate and determine whether to process in this in a particular order or any other order, right? That you can determine from the scheduling measure. So coming to the first scheduling measure, that is called as top level. Top level is called as a T level. It is also called as soon as possible, right? ASAP. Okay. What it says? It is the path from the entry task to the given task Ti. So it is going to determine the path from entry task. What is the entry task? Entry task is always T1, and given task may be anything. It may be 1, it may be 2, it may be 3, 4, 5, 6, anything, right? So entry task to the given task Ti. So sometimes you can see there are more than one path exist. Okay. So if more than one path exists, then you have to select the maximum path. Okay. Sometimes some scheduling measures also says that if there are more than one path exists, then you choose the minimum one. Okay. But here in this scheduling measure, or you can say T level or top level or ASAP case, we choose the maximum path. And while you are calculating the path, you will come across a set of computation time and communication time. So all computation and communication cost between the entry task and the given task are added to get the T level of the task. But you will not consider the computation cost of a given task Ti. You are not going to consider given task Ti, and rest of the things you need to consider. So let us take an example so that you will understand actually how actually this T level works. So as I said, entry task, the measure for T level is, or T level, or you can say as soon as possible. or top level. Okay, the measure says that what you have to do, you have to find from entry task to given task. Entry task to given task. For example, if you calculate for T1, okay, so what it is, you have to say entry task. Entry task is T1 and given task is also T1. So you are finding the T level of T1 to T1. Okay, T level of T1 can be determined as T1 to T1 in the sense that is entry task T1 to the given task T1. So you need to see here the computation and communication time of your entry task to the exit task, entry task to the given task. But as entry task and given task is same, and you are not going to consider the computation time of the given task Ti, so T level of T1 is equal to 0. Similarly, if I ask you to calculate the T level of T2, then you can see there is a path exists between T1 to T2. There is only one path exists in between T1 and T2. So if you come across that path, then you have to add 5 is the computation time of T1. Communication time between T1 and T2 is 4. And computational time of T2 you are not going to consider. That's why I told you, except the computation time of the given task. So here, in the case of T2, your given task is T2 and entry task is T1. That's why you need to calculate it is 5 plus 4, which is equal to 9. Similarly, if I ask you for T3, you can see there are two paths exist to reach T3. You can go for T1, T2, T3, or you can go directly from T1 to T3, right? If you go for T1, T2, T3, it is nothing but 5 plus 4 plus, this is 5 plus 4 plus 7 plus 12. 7 plus 12. Okay, I'll not consider the computation time of T3. But if you go directly this path, it is nothing but 5 plus 3 plus, no, I am not going to consider this one. So it is 5 plus 3 only. So here you will get 12 plus 7, 19, or 23 plus 5, that is 28. Here 5 plus 3, you will get 8. Right? So in this way, you can calculate if there are multiple paths are there. But as I said here, if you remember that if there is more than one path exists, then you have to select the maximum path. So which one is maximum path among these two? Obviously, first one. So you will consider the T level of T3, it is 28. Now consider for T4. So you can say it is T1 to T4 directly. There is no other path. So it is nothing but 5 plus 7. 5 plus 7. You will not consider this type. So it is equal to 12. Okay. Now if I go for T5, T5 case, you will get multiple paths. What are the paths exist for T5? You can follow this path, or you can follow this path also leads to T5. Okay. So if you follow the first path, that is T1 followed by T2 followed by T5, the cost is 5 plus 4 plus 7 plus 8. Okay. Similarly, if you follow the second path T1, T4 and T5, okay, so the path is 5 plus 7 plus 4 plus 9. Okay, 9. You will not consider the computation time of T5. So it is 5 plus 4 plus 7 plus 8. You will get, I think it is 24. Here it is nothing but 12, 4, 16, 9. It is, I think it is 25. So if there is multiple path, you will choose the maximum path. The maximum path is 25. Okay. So in this way, actually, you have to calculate the T level of a graph. Coming to the last one, that is T6. If you go for T6, T6 is nothing but you can go in multiple ways. You can follow this path. Okay, if you follow this one, then it is 5 plus 4 plus 7 plus 8 plus 5, 4, 7, 8, 2 plus 5. Okay, you will not consider the computation time of T6. Okay, so I think you will get here 9, 7, 16, 8, 24, 26, 31, right? I think it is correct. 15, yes. Then if you follow this particular path, in this way also you can reach to your destination, right? So it is nothing but 5 plus 4 plus 7, okay, plus you can say 12 plus 3 plus 4, okay. So you will get 9, 7, 16, 28, 31, or 35. Similarly, you can follow this path directly, right? So it is nothing but 5 plus 3 plus 3 plus 4. Okay, 5 plus 3 plus 3 plus 4. Okay, so it is coming around 9 plus 6, that is 15. Similarly, you can follow this particular path, that is 5 plus 7 plus 4 plus then if you follow this path, then it is 9 plus 2, 9 plus 2 plus 5. So it is nothing but 12 for 16, 16, 9, 25, 30, 32. Okay. And if you follow this path, 5 plus 7, 12, this particular path, then 5 plus 7, 12, 12, 4, 16, 11, 27. Okay, so you will get 27. Like that, you will get so many paths, right? I think you will get 5 paths here. Okay, so after finding all the path, you have to find the maximum of it, right? So if you calculate the maximum it out of these path, the maximum one is 35, right? That's why the T level of this workflow is 35. Okay, so in this way, you can actually calculate using the T level. Is it clear? Is it clear how to calculate the T level? This is the T levels what we have calculated. We have calculated 8, 22, 24, 25. Only last case 31 and 15 I need to add here, right? 15 and 31 need to be added here. Is it clear? Is it clear how to calculate T level? Okay, we'll proceed to the next scheduling measure. The next scheduling measure is called as bottom level. So in the bottom level or B level, it is the path from the given task Ti to the exit task. So till now you have calculated from, if you go for top level, you have calculated from entry task, right? You have calculated from entry task to given task, right? So that is called as your T level. But when you calculate given task to the exit task, we call that as a B level, right? But it includes the computation cost of the exit task. While you are considering this thing, you will consider the computation cost of the exit task. Previous case, we are not considering the computation task of cost of the given task. But here you are considering the computation cost of the exit task, right? So what we can do, let us see how to solve this one using B level. So this is the B level calculation. So as I mentioned, you have to calculate the given task to exit task. So exit task is same for all. That is T6. So if you calculate exit task for, let's say, the B level of T6. So it is the exit task. Let's say the given task is also T6. So the cost is 8 only. So you can see the cost is 8. So if you go for T5, so T5 is your given task and exit task is T6. Okay. So what is the cost? The cost is 2 plus 5 plus 8. 2, 5 and 8. So you will get 15. Right? Now if you calculate T4 to T6, that is nothing but the T level of B level of T4. So it is nothing but you have multiple paths to reach T4 to T6. So you can follow T4, T5, T6, or you can follow the direct path, that is T4 to T6, right? So if you go for T4 to T5, so it is nothing but 4 plus 9 plus 2 plus 5 plus 8. Okay. Or if you go directly, it is 4 plus 11 plus 8. So I think here you will get 13, 28. And here you will get 15, 8 is 23. So 28, 23, that out of that maximum is 28. Right, that is nothing but the B level, right? Similarly, if you calculate B level of T3, B level of T3 is nothing but 3, 4 and 8. So how much you will get? 7, 8 is 15. Here you can see it is 15. Okay. Now go to T3. T3 is done. Okay, we will go for T2. T2, you will find multiple path. You can follow this path or you can follow this path, right? So if you follow this path, then it is 7 plus first path 7, 8, 2, 5 and 8. If you follow the second path, it is 7 plus 12 plus 3 plus 4 plus 8. So I think you will get first case you will get 15, 20, 20, 30, right? This one you will get 19, 3, 22, 22, 26, 28. Okay, 34. Yes. So the maximum among them is 34. So that is nothing but the T level of T2. Now, if you go for T1, there are multiple paths, you know, 1, this is the first path, right, which is nothing but 5 plus 4 plus 7 plus 8 plus 2 plus 5 plus 8. Okay. If you follow this path, so it is 5 plus 3 plus 3 plus 4 plus 8. And if you follow this path, it is 5 plus 4 plus 7 plus 12 plus 3 plus 4 plus 8. And if you follow this particular path, let T4, then T5, then T6. So it is 5 plus 7 plus 4 plus 9 plus 2 plus 5 plus 8. And if you follow this path, okay, it is nothing but 5 plus 7 plus 4 plus 11 plus 8, right? Let us sum these values. 9, 7, 16, 24, 26, 31 and 39. So first value is 39. Second value you will get 11, 15, 8, 23. Third one you will get 9 plus 7 is 16, 28, 31, 35, 8, 43. Here you will get 12 plus 4, 16, 9 is 25, 27, 32 and 8, 40. And the last case you will get, I think, 12 plus 4, 16, 27, 8 is 35. So out of this, the maximum one you are going to get in the case of this one is 43, right? So 43 is the maximum one. Okay, you can see all these values I have written 39, 23, 43, 40, and 35. Okay. So in this way, you can calculate the B level of the various tasks. Okay, in the order. Okay. Yeah, I forgot to tell you. Once you find this order, what you actually will do? So this is actually T level, right? So once you find the order, you will choose the least T level in order to dispatch the task. The least T level is T1. Okay. Then T3. Okay. Sorry, maximum one if you took. Just a minute. Okay. 0, T1 you need to schedule first, followed by T2, because T2 is having 9, then T4, then T5, then T3, then T6. In this order, you have to dispatch the task. But now we are discussing about B level. Once you determine this B level, if I ask you to find the order in the B level, so you will choose the maximum B level. T level case, you are choosing the minimum one. But B level case, you have to choose the maximum one. So B level case, you will get, I think, T1, followed by T2, then T4, then T3, T5, there is a tie. So you follow numeric order. Okay. And the last one is T6. Okay. In this order, you have to dispatch the task by following the scheduling measure as a B level. Okay. Any questions till now? Any doubt up to this? Okay. So I'll proceed to the next scheduling measure. The next scheduling measure is called a static bottom level. Okay. Starting bottom level is called as S level. Okay. Or it is also called as SL, static bottom level, or you can say static level. So it is more easy in comparison to T level and B level, because T level you are doing a lot of calculation, B level, but here the calculation is much more easier because it takes only the computation cost. But how to calculate which from which task to which task you are going to calculate the computation cost? That is nothing but given task Ti to the exit task. So B level also, as the name suggests, B level. B level case means you have to calculate from given task to the exit task. But in the previous case, you are considering the computation time as well as the communication time. But in this case, you will consider only the computation time. So let us see. So it is given task to exit task, right? Given task is different. Exit task is always T6. But you will consider only computation cost. Let us go for T6. So it is 8 only, right? If you go for T5, so it is 2 plus 8, so that is 10. If you go for T4, there is two way. You can go for 4 plus 2 plus 8 if you follow this path, or you can go for 4 plus 8 directly by following this path. Okay, so here you will get 14, here you will get 12. So 14 and 12, you will choose the maximum one. Okay. Now coming to T3. T3 case, it is 3 plus 8, that is 11, right? Coming to T2 case, you will see there are different paths. There is one path here. there is another path here, right? So if you follow this particular path, then it is 7 plus 8 plus 2 plus, sorry, just a minute. So you have to calculate only the computation time, right? So yes, 7 plus 2 plus 8. 7 plus 2 plus 8. If you follow this path, then it is 7 plus 3 plus 8. 7 plus 3 plus 8. So first case you will get 17. This case you will get 18. So the maximum among them is 18. Right? You can see here T2 case. Now coming to the first case, that is T1. You can follow this path. If you follow this path, it is 5 plus 7 plus 2 plus 8. Okay. If you follow this path, then it is 5 plus 7 plus 3 plus 8. Okay. If you follow this particular path, then it is 5 plus 3 plus 8. If you follow this path, then it is 5 plus 4 plus 2 plus 8. And if you follow this path, then it is 5 plus 4 plus 8, right? So if you calculate all these values, you will get here 22. Okay. Here you will get 23. Here you will get 16. Okay. Here you will get 19. Here you will get 17. Right. So out of this, the maximum one is 23. Okay. So once you calculate this static bottom level, or we call it a static level, you have to dispatch the task based upon the maximum static level. So if you choose the maximum static level, you will get T1, then you will get T2, then T4, then T3, then T5, then T6. In this order, you have to dispatch the task. Okay. So in comparison to the previous one, this is a simpler one because as we consider only the computation time, we are not considering the communication time. Okay. Sometimes we assume that the communication time is negligible, or we consider that it's 0. Right. In that case, you can consider only the computation time. Through computation time, you can calculate static bottom level, and you have to choose the maximum value. Okay, if there are multiple paths are there, and you have to arrange the order in such a manner that maximum path, maximum value. Okay, the maximum static level need to be assigned first. So T1 is coming first, then followed by T2, T4, T3, T5, and T6. Okay, then the last one, last settling measure here we want to see, that is called as late as possible, which is called as ALAP. It calculates how much time the execution of the given task TI be delayed. How much you can delay the process of execution. So in order to find this path, you need another measure that is called as critical path. Critical path is the maximum length path from source to destination. Okay. If you calculate maximum path from the source to destination, in this case, you will get the maximum path is 43, right? Which you have calculated also in the case of, I think, in the case of B level. So the maximum path from, if you calculate all possible path from source to destination, that is T1 to T6, or you can say entry task to the exit task, you will find that is 43, right? So that is the maximum path from T1 to T6. So you have to first determine the critical path, which is equal to 43, and you have to subtract the path from exit task to the given task, because ALAP is nothing but the path from exit task to the given task. Okay, exit task to the given task. So ALAP, you have to determine as usual, that is in comparison to the previous one, because first one says that entry to given task, right? That is your T level. Given to exit task, that is your B level. Given to exit with only considering the computation time, that is your static bottom level. Okay. And as late as possible says that it is exit task to the given task. Don't consider that given task to exit task is same as you can say exit to given. That is different, right? Why it is different? Because you are subtracting it from critical path. That's why different values is going to come. Okay. Now we have to calculate it, but I'll tell you, you have already calculated the B level. Let me write the B level values here so that we can compare later. If you calculate the B level of T1, I think it is 0. Okay, let me check. This is the B level, which is from the given task to the exit task. 43, 34, 15, 28, 15, 8. These values actually we need. B level is 43, as I said, 43, then 34, 15, 28, 15, and 8. T2, T3, T4, T5, and T6. And you know the critical path. Critical path is nothing but 43 for all. Right? Right? So you can see 43 minus 43, first value is 0. 43 minus 34, you will get 11. Okay. But that is not exactly that is as late as possible, because the calculation is slightly, you can say, different. Okay. Because you have to consider all possible path. Right? Because this is not only 34. If you go to that slide, you can see not only 34, it is also having 30. Right? So if you subtract 30, then you can say you will get, if I take 30, then I will get the value as 13. Okay, 30 case I will get 13, 34 case I will get 9. Okay, you can see here T2, 13 and 9 you are getting, right? So out of this 13 and 9, whichever is minimum, you have to choose that one. So the minimum one is 9. That's why we're choosing 9. Or similarly, 43 minus 15. Okay, if you want to find multiple path, you have to do like this. Otherwise, 43 minus 15 is 28. 43 minus 28, you will get 15. 43 minus 15, you will get 28. 43 minus 8 is 35. So this will give you the as late as possible, or you can calculate also. Right? If you want, you can calculate also. For example, let me show you the calculation one. For example, let us go for T4. This is your T4, right? You have two paths, but you have to calculate critical path, that is my 43, minus you have to backtrack it. Backtrack means 8, 5, 2, and 4. 8, 5, 2, and 4. How much you will get? 43 minus this is 13 to it is 15 for 19. Okay, so it is 13. Am I correct? 8, 5, 2, 4. So yeah, 43 minus 19 in the case of T4. Okay, so how much you will get here? 24. Yeah, you will get 24. But there is another path. Okay, exit path. Okay. So you can also follow this path. So I can write in the case of T4, there is another path which you can say 43 minus 8 plus 11 plus 4. So 43 minus 23, you will get 20. Okay. Oh, I have missed one value here. That is 9. That's why the value is coming different. This is plus 9. So 9 means it is going to come as 28. So 43 minus 28, I'll get 15. I'm sorry for this. Okay. So I missed this particular value 9. That's why the value is different from whatever I've given here. So now it is correct, right? You are getting 15 and 20. You can see in the T4 case, you are getting 15 and 20. So out of 15 and 20, you have to choose the minimum one. Minimum one is 15. Okay. So that is nothing but our ALAP. So here you can see you have to choose the minimum ALP first. That means T1 need to be scheduled first. Then the minimum one is T2. Okay. Next minimum one is T4. Next minimum one is T3, T5, then T6. T3, T5 in any order, but we will follow the numeric order to calculate it. Okay, is it clear that how to calculate as late as possible? Okay, this is the process that you have to follow. These are the 4 scheduling measures I told you. Many researchers have developed different scheduling measures, not only this T level, B level, these are very old measures. But I just want to tell you, in order to find the ordering of the task, what solutions you can think. Okay, for that I told you these 4 different scheduling measures. Okay, let us stop here. We'll discuss the rest of the things in the next class.